Hello again. So this is the practice quiz for our third unit on circular trig. So we want to do some conversion on the first two, and the idea is to multiply by pi over 180 or 180 over pi. And again, a good way to think of this is to think about you want to cancel the pi out of a radian measure. And then just look to do 4 times 180 over 3 in your calculator. That gives you 240. And then reduce 135 over 180 in your calculator, you get 3/4. And then just attach the pi on the end. Pretty simple with converting. Tier 2, this is going to be on the quiz. This is just for memory's sake. I want you to know 90 degrees is pi over 2. So it's just 1/4 of 2 pi, which is pi over 2. 180 is half of 2 pi. 270 is 3/4 of 2 pi. And then 360 is all of it. So in the unit circle, r is 1, making 1 lap equal to 2 pi. Find the coordinate on the unit circle that corresponds to an angle of 3 pi over 4 radians. State the coordinate in exact radical form. So you are doing cosine of 3 pi over 4 in radians and sine of 3 pi over 4 with the memory of doing the converting into exact radical form, which is this right here. And eventually I want you to remember it. And it has to do with the special right triangles. This is going to be one of the 45, 45, 90 right triangles. Again, if you don't have a calculator, you might be able to type this into an internet search bar, and it might, let's just play a little game here of typing this in. So we'll have to go to a new window here. Sine of 3 pi over 4. Just spell the word pi and then do exact. Oh, it didn't put out anything good. Let's erase the word exact. Looks like you, so 0.7071. There we go. That's what you need. Again, this will do it. That's the square root of 2 over 2 that I want you to have memorized. This will do it. And it's good to know that you can just literally type things into an internet search bar. You'll have to go to your mode and change to radians on the calculator though. And this will give what you need. Cosine of 3 pi over 4, and then sine will be positive 0.7071. So this is going to be negative square root of 2 over 2, positive square root of 2 over 2. That's what I want. I want the exact values. It has to do with the 45, 45, 90 right triangles, 30, 60, 90 right triangles. Number 5, find the arc length. So let's use this again with the knowledge that 90 is pi over 2. So 7 pi over 2 centimeters. It's just good to always think of arc length as a radian measure because that's what it is, and to always use radians so there's not a confusion there. Number 6, find the measure of the angle that's coterminal. So they want the angle measure of this. It is counterclockwise, so it's going to be positive. So you're just going to do 2 pi minus pi over 4. Come back to it. Or you can do 3 pi over 2 plus pi over 4. However you want to do this, it will deliver the same thing. I think it's easier to do this, to go all the way around, then come back. And then you're just going to do on your calculator 2 minus 1/4, which is going to be 7 pi over 4 for either one of these. Okay, what is the y value of the coordinate on the unit circle that corresponds to the angle in problem 6? So we are doing sine of 7 pi over 4. And that's going to be negative 0.7071, so on and so forth. So we're going to just convert that. And using this here to negative square root of 2 over 2. Okay, 8, a circle has an arc length of 3 pi. So got this formula again. With a central angle of pi over 4, so good, it's given in radians. And so 3 pi equals r times pi over 4. And then remember how this works. We can do a little cross product, eliminate the pi's first. So 3 over 1 would equal r over 4. And then just cross product r is 12 feet. Simple enough. All right, 9 and 10 deal with arc length, but not in the typical way that you think about it. So we are doing r times theta, but the better way to think of it is in this manner, is to think of it as the fractional piece of the circumference. And the same down here. So what, 15 minutes out of an hour. So 15 over 60 times 2 pi r is 16. So we can reduce this to 1/4 times 2 times pi times 16. So I'm getting at, with arc length, let me go back to the notes here. I'm getting at like this fraction piece times 2 pi r, that this fraction can be anything. It doesn't necessarily have to be an angle. Kind of a weird idea there, but that's what is going on. If you wanted to, you could do the theta as pi over 2. That'd probably be easiest, times 16, which would be 8 pi. That's exactly what we get here. So you could figure out what the angle is in radians and then just do it. And then that is 25.1 when you crunch it out feet. So if you wanted to use this and just do 15 minutes, you know, out of 60 minutes is a pi over 2 angle, you could do it that way. So here we have 22 feet plus, this is a quarter circle. So 2 of them is a half a circle, times 2 pi times r, which is going to be 12. So that's literally what you do. Or you could think of it as, if you're doing the r times theta, the theta would be pi times 12. Well, pi is going to happen because you're going to do 1/2 times 2 pi, which is pi. And putting the 2 quarter circles together. So this, when you crunch it all out, is 59.7 feet. Okay, and there's the practice quiz. This will should take you through Thursday, and then Friday and Monday, my pre-calc students, next year's pre-calc students, will have a little assignment to do. So actually, it's going to be Tuesday, okay, let's see, the 8th is Friday. I think Tuesday, May 12th, before we pick up again. So that'll give you a little break so that you can get caught up on things. So this will take us through next Thursday, May 7th. And then on the 12th of May, which is a Tuesday, we'll pick back up again. Pre-calc students will have something to do on the 8th and the 11th.